Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. It's 3 a.m. Your phone lights up. Your AI assistant just did something. Not because you asked, not because you were online, it just acted. That's the eerie question at the heart of OpenClaw architecture, part 2 concurrency isolation, and the invariants that keep agents sane by Vinoth Govindarajan. But here's the twist, it's not haunted, it's concurrency. And in this episode, we are diving into the real reason agents feel spooky and how OpenClaw makes them boring in exactly the right way. The moment you connect multiple chat surfaces, add heartbeats, cron jobs, webhooks, long browser tool chains, you didn't build an AI assistant, you built a concurrency system. And if you don't define invariants, hard rules that must never break, your agent won't fail loudly. It will fail subtly. Half written files, duplicate sends, contradictory actions. That's not intelligence. That's broken coordination. The most important invariant, single writer per session. OpenClaw enforces this with a lane-aware FIFO queue. Each session gets its own lane, session key. Only one active run can touch that session at a time. No interleaving tool calls. No transcript corruption. No two thoughts at once. Suddenly, the agent stops feeling magical and starts looking like a disciplined state machine. But serialization alone isn't enough. After the session lane, every run flows into a global lane. That's your throttle. Dot capped by agents. Dot defaults. Dot max concurrent. Why? Because LLM calls are expensive. Rate limits exist. Shared resources collide. This is not about wipes. It's about protecting your own infrastructure from your own agent. And here's the elegant part. Typing indicators can fire instantly, even while the run waits. User experience feels responsive. System guarantees stay intact. Now comes the real question. What happens if a user sends a correction mid-run? OpenClaw doesn't hide this behind AI behavior. It exposes queue modes. Collect, follow up, steer, dot steer backlog, interrupt. The most fascinating one, steer. Here's the contract. After every tool call, the queue is checked. If a new message exists, remaining tool calls are skipped. The new message is injected. Not inside the tool call, that would be unsafe. Not ignored, that would be bad UX, but at tool boundaries. It's surgical preemption. That's the moment the system stops feeling chaotic and starts feeling intentional. Now let's talk plumbing. Real channels redeliver messages. Reconnects happen. Retries happen. OpenClaw uses short-lived dedupe caches keyed by channel session message ID. No accidental double runs. And humans? We type in bursts, debouncing batches, rapid text messages into one turn. Attachments flush immediately. Control commands bypass debounce. These are tiny details, but they are the difference between stable and spooky. Serialization prevents two writers. Isolation prevents wrong context. Session keys define boundaries. Direct chats collapse to a primary session. Group chats get their own keys. And here's where it gets security relevant. Without secure DM mode, dmScope per channel peer, private context can leak. The gateway is the source of truth. Clients don't reconstruct state from transcripts. They query the gateway. Control plane first, always. Even perfect serialization isn't enough. Two different sessions could mutate the same external resource. Tool calls might not be idempotent. So OpenClaw adds global throttling, idempotency keys for side effects, mandatory handshake, first frame must be connect, events aren't replayed, you refresh to recover, constraints first, not magic, guardrails. If you're building your own agent system, steal the invariants, normalize inputs, resolve session keys, enforce single writer, throttle globally, define mid-flight behavior, add dedupe, add debounce, persist transcripts. Because the layer that decides whether your agent is a toy or something you can leave running overnight isn't the prompt, it's the invariance. And in part 3, we step into memory and state ownership, where context management stops being a prompt trick and becomes a systems problem. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.